Hi everyone, welcome to your very first AP Calculus AB video. So this is the first video for your summer packet, and really this video has two purposes. The first thing we're going to do in this video is we're going to review a couple different kinds of functions, mainly piecewise and rational functions, just to make sure you guys are comfortable and kind of remember what those are all about. And then really the big goal of this first video is to show you why studying our first topic in calculus is going to be important, why we even bother doing it at all. So we're going to go ahead and get started here with some of the piecewise functions that you see. So you can see in the directions here it says use the following graphs to find f of 2. So since we're just starting out in calculus, I am going to do a bit of a review on some of the notation stuff. It should be things that you are already comfortable and familiar with, but I'm going to go over them just to make sure that we all start the year out on the exact same page. So when it says f of 2, what this is really asking you to find is find the y value when x equals 2. So we know that this number inside of the parentheses here is always going to be an x value. So in this particular case, we're going to find the y value when x equals 2. So we can do this in two different ways. We can look at the equations that we were given, so for the function, or we can look at the graph. So if we look at the graph here, here's x equals 2, and we need to go up until we see a closed circle on the function. So that happens to be right here. And we can see then that this is a value of 4. Now we could also do that, like I said, by looking at the actual function that we were given. So since we're finding y when x equals 2, we know that we're going to be looking at the very first piece of our piecewise, because that's when x is less than or equal to 2. So if we plug a 2 in there, 2 times 2 is 4, we end up getting the same value. I'm going to take a little bit of a detour really quick just to talk about how to graph piecewise functions. These ones we already gave to you, but just as a quick review to remind you how to do that. So the first thing I do when I'm graphing a piecewise function is I figure out where the breaking point is. So in this case, I know that there's going to be an issue at x equals 2 because that's where the break in my domain is. So this isn't actually part of the graph, but I almost draw like a vertical asymptote here to kind of remind myself that, hey, this is where things are going to change on this graph. All right. Then what I do, I'm going to do this piece first. And I know that that's a line, right? 2x is a line. So I'm going to make an xy table. And I know that I need x values that are less than or equal to 2. So I'm going to go ahead and do maybe 0, 1, and 2. All right, and I'm going to remind myself, because it's equal to 2, that at 2 I'm going to have a closed circle, because it is equal to 2. So if I plug in 0, 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4. And I can go ahead and graph those points. So 0, 0, 1, 2, and then 2, 4, and that means that this is that first line. Okay? Then I do the same thing for the second piece. I make an XY chart. So here's my second piece. And this time I want x values that are greater than 2. So I'm going to start at 2, but I'm going to remind myself that it's going to be an open circle. And then I'm going to do 3 and 4. So let's see, 4 times 2 is 8, minus 4 is 4. 4 times 3 is 12, minus 4 is 8. 4 times 4 is 16, minus 4 is 12. Now our graph doesn't go up, really it doesn't even go up to 8, but we can see then that 2, 4, I could plot an open circle there, but remember, it is actually closed in this particular case because of this function over here. But then 3, 8, I know is going to be somewhere up here, and so I could draw the rest of the graph going through like that. So just, I know a little bit of a detour there, but just a quick review on how to graph piecewise functions, just in case you have to do it, later on. So let's go ahead and keep going with the point of the video here. So we need to find f of 2 on this particular graph. So again, we find x equals 2, and we're going to go up to the function where we see a closed circle. So the closed circle is right here, which is also at y equals 4. Now we can see that there's an open circle up here, but we know that since we're looking for f of 2, we want the closed circle. All right, on our next one here, here's x equals 2. There's an open circle here, but I need to keep going until I get to that closed one. So that's also 4. We've got this one here. Here's x equals 2. And this looks like it could be a complete line, but then there's this hole here. And we have to keep going until we get to the actual closed circle where the function value is. And there's 4. And then I'm going to slide my paper over. We've got one more graph that we have to look at here. So when we try and find the y value when x equals 2, or in other words, f of 2, if I look at this graph, I can see that there's actually no closed circle for x equals 2. There's an open circle here, and then there's nothing above it or below it to actually close it. And so what we say then is we say that f of 2 is undefined. There is no y value for that particular x value. Okay? And then what we want to do is we want to look at all of these. And really our first question down here kind of guides us to this. But the first question is, what do you notice about the values of f of 2? So hopefully you guys can look at this and you can see that for these first 4 graphs, all of them have the same function value. So in the first 4 graphs, the value of f of 2 is 4. However, if we look at those graphs, those all look very different. So however, the graphs of the functions look very different. So for example, if we look at the first one, we can see that there's 2 distinct pieces, but they happen to be connected because on the breaking point, they ended up having the same function value. And so while it's 2 different pieces, they are actually connected. I could draw this without really picking up my pencil. I would just be changing the slope of the line once we hit x equals 2. For this second graph, though, we have 2 very distinct pieces, and there's this empty space. There's almost this jump in between the 2 pieces. For this one, again, we've got the 2 distinct pieces, and then our function value is actually somewhere not on one of those pieces. Whereas on this one, our closed piece was connected, our closed function value, was connected to one of those pieces. So even just these 2 are different, even though they both have a break in them. For this fourth one, we can see that it was almost a complete line, but we had this particular point that was really removed from the line and made this hole here. So when we look at these, even though all 4 end up being f of 2 equals 4, these graphs are completely different from each other. And so what we want to look at is this next question. Does finding the value of f of 2 give you a complete picture of what the graph looks like close to x equals 2? And we can tell just by looking at those 4 that no. The value of f of 2 or in other words, the y value at x equals 2 is not sufficient to provide a clear picture of the graph around x equals 2. So we have to, ooh, sorry, you couldn't see that. Let me move that up a little bit. The value of f of 2 is not sufficient to provide a clear picture of the graph around x equals 2. So in other words, we need to be able to tell what's really going on here. Are these two pieces connected and just have different slopes? Are they not connected, but the function value is part of one of the pieces? Is the function value completely distinct from the two different pieces? Or was it just kind of moved out of the way? So that's why this first topic that we're going to look at is going to be so important, because we're going to address these different types of disconnections here. Before I let you guys go, I do want to talk really quick about rational functions. These were all piecewise functions that we looked at. So I'm going to just go over here where we've got some blank space. Excuse me. And I want to talk I'm so sorry about that. I want to talk about rational functions. So hopefully just that alone helps ring a bell. Rational functions. Remember, ratio means that it's a fraction, right? So for example, let's look at the function f of x equals x squared minus 4 over x minus 2. Now hopefully when you guys look at that, you can see right away that the top of that function, the numerator, is a difference of squares, which means we can factor it as x minus 2, x plus 2. And then the denominator stays as x minus 2. And when we look, that means we can cancel these x minus 2's, and that's going to create a hole on our graph. So we get f of x equals x plus 2. If we were to graph this, we know then that we would have a hole at x equals 2. If we plug in 2, we'd get 4, so that's where the hole is. So at 2, 4, we know we've got a hole. The rest of this function, though, is going to look exactly like the line x plus 2. So if I plug in 0, I'd get 2. If I plug in 1, I'd get 3. Let's go 1 past it also. Let's do 3, 5. And we can see then that this is a line, and we just have this hole missing in the middle. Or not in the middle, but at this point. And it's kind of like this function here. So with a piecewise or with a rational, we could end up having this hole. Okay, so I don't want you guys to only think that this happens with piecewise functions. It also happens with rational functions. We could also have a rational function that looks like this. So let's say f of x equals 1 over x minus 2 quantity squared. If we looked at that graph, we know that there's going to be a vertical asymptote at x equals 2. And we know that we've got a piece that goes up like this, and another piece over here. If I wanted to find f of 2 for this particular graph, I can't do it. F of 2 is undefined. If we look up at this graph, f of 2 is also undefined. So if I just walked up to you and said, hey, on the graph f of 2 is undefined, how do you know which one this actually is supposed to be? You don't. This graph, f of 2, is also undefined. All right, so this is why this first topic in calculus is going to be so important, because it's going to help us get a better picture of what's going on with these functions, because we're not only going to be focusing on function values, we're going to be focusing on what's going on around those particular function values. All right, so hopefully you guys took some good notes, and that hopefully this wasn't too much of a stretch either. This should all be somewhat of a review, maybe just thinking about it a little differently. You have no practice after this particular video, so you can just go right ahead and jump into the next video. Thanks for watching.